Hi, my name is Vaidehi Zala, and today I'm going to be presenting the birthday polynomial project. The scientist I chose was Ada Lovelace. First, I would like to give some background information on my scientist. Ada Lovelace's full name was Augusta Ada King, the Countess of Lovelace. She was born in London, United Kingdom, and born on December 10, 1815. She was married to William King Noel, 1st Earl of Lovelace. She was credited as the world's first computer programmer. She was known for her understanding and work on the analytical engine with Charles Babbage. Ada Lovelace was a very accomplished woman as she was an English mathematician, writer, scientist, and mother. Sadly, her life was short and she died on November 27, 1852 due to uterine cancer. By using Ada Lovelace's birthday, the numbers used to create the polynomial are 1, 1, 2, 7, 1, 8, 5, 2, and the polynomial I will be using for this project is f of x equals negative 7x to the 6th power plus x to the 5th power minus x to the 4th power minus 2x cubed plus 8x squared plus 5x plus 1. This is my table of values that consists of the x and y coordinates of my polynomial's turning points, zeros, y-intercept, and other points. My polynomial's two zeros are negative 0.863, 0, and 1.123, 0. And its y-intercept is 0, 1. Throughout this presentation, I'll be using three specific colors to identify three different types of points. I'll be using orange to represent the turning points, pink to represent the zeros, and green to represent the y-intercept. Here's my polynomial function graph. My turning points, roots, and y-intercept are all labeled and the graph opens downwards. This slide will analyze my polynomial. The degree of my polynomial is 6, an even and positive number. The leading coefficient of my polynomial is negative 7, an odd and negative number. By looking at the leading coefficient, I can know the left and right-hand behavior of my polynomial. The leading coefficient is negative, so the graph's left and right-hand behaviors fall. There are three turning points in my graph. The yellow dot shows the turning points. The polynomial's number of turning points can be determined by subtracting n, which is 6 and 1. So the maximum number of turning points my polynomial can have is 5. This is true and evident in my graph. My polynomial has two roots and they can be identified with the pink dots. I found my roots using synthetic division and Desmos, the graphing calculator. Finally, the y-intercept is 0, 1, and this is shown using the black dot. By analyzing the polynomial, I was able to find the three turning points, the two roots, and the y-intercept. I used synthetic division to find all of these values. Understanding and identifying the degree led me to find the maximum number of turning points I can have, which is 5. Knowing the degree also helped me reason my roots. Technically, there should be 6 roots because my degree is 6, but by using Desmos, I understood that there are 2 real zeros and 4 imaginary zeros. By figuring out the leading coefficient and its properties, I was able to figure out what the left and right-hand behavior of my polynomial was. Below are the tables for my turning points and zeros. The table on the left with the orange border shows my turning points, and the table on the right with the pink border shows my zeros. Ada Lovelace had a life with many ups and downs just like my graph. With her parents' weak relationship, she was left alone with her governess many times. Her governess taught her history, literature, mathematics, music, and geography. As Ada broadened her knowledge, she became capable enough and wrote her first book at the age of 12 about flight dynamics. However, soon after, her father died and she became bedridden because of measles. Ada experienced a form of paralysis that restricted her abilities. Although this was a negative experience, she was able to learn a lot of new information by spending hours reading about different subjects. After recovering enough to be able to ride horses, she met Charles Babbage, a founding father of the computer. He introduced her to his difference machine, which performed simple calculations. She was extremely interested and fell in love with the idea of what a machine can do. As she was making a family in 1843, she also translated Charles' work on the analytical engine into English. Her notes on his work were so detailed and extensive, and they ended up being more important than the translation itself. Her notes helped improve the analytical engine, which is now known as the earliest model of a computer. Without her notes, the idea of a computer and software wouldn't have been brought up until much later. Her knowledge on the machine as software gave her the prestigious title of the world's first computer programmer. Shortly after her work on the analytical engine, she was sick again, but this time because of uterine cancer. She became addicted to the pain medicine, and in 1852, Ada Lovelace passed away. Thank you for watching.